Our next lesson in counting is permutation when objects are identical. So if you consider the words bed and bee, the word bee has two identical objects in it, the two E's. They're indistinguishable. How does the number of ways that the three letters words in each word can be arranged differently? So let me just try with the word bed. And in this first column, I've just organized, if B goes first, I can arrange the other two letters. And if I arrange E first, we have these other ways. And if D occurs first, it's the other ways. Or perhaps if you're just thinking BED, shouldn't that be 3 factorial ways? Sure. There are 3 placements using the fundamental counting principle, 3 different places. So first letter can be one of 3 options. Second word, one of 2. Third, or 3 factorial, 6 ways. No, how about B? Well, B might look a little bit different. Well, let's try to put B first. So the letter B, there's only one way to spell it when the letter B happens. It's B. If you switch the E's around, it'll look like B, the same word. Now, if we put the letter E first, we can arrange it in 2 different ways. So we're going to try to develop a counting principle when we have identical objects, like 2 letters. So let's look at the definition. A set of n objects with A of one kind that are identical and B of a second kind that are identical and C of a third kind that are identical and so on can be arranged in n factorial divided by A factorial times B factorial times C factorial different ways. Right about now, before we get too much into it, I'm just going to say it is implied that there's brackets around the denominator when you're using a calculator. So let's take a look at some examples. The word salami. So probably the first thing that I'm going to do is I'm going to decompose the word salami. So I'm going to put the S first. I'm going to put the A's together. LMI. I just put anything that was identical close. And what I can see is that there are 2 A's side by side. Now, how many ways are there to arrange the letters of salami? Well, there's going to be 360 ways. Maybe you want to ask why, and that would be a fair question. And that is simply because what we have in the numerator, we have 6 objects. In total, salami has 6 letters. We have in the bottom, this represents the 2 A's. So it's 2 factorial that we have to divide by. Now, let's move on to our next word. So we're going to try to make a different arrangement using the letters in element. So what I like to do, and maybe this is my own quirk, I like to decompose the letters. Element. So it starts with an E. I'm going to put all E's together, and then the L, M, and T. I count how many letters are in element. Well, there's 7. And I count how many letters are in my decomposed element, and there are 7, so I didn't miss one. And what I notice is that there's 3 identical E's in here. So I'm just going to set this up. The number of letters in element, or objects in element, are 7. So the top is going to be 7 factorial divided by 3 factorial because I have 3 identical E's, right? So this represents the E's, 3 E's. So that's why it's 3 factorial. Now 7 factorial divided by 3 factorial is going to be 840. All right. So we do see aardvark, a very weird word, aardvark. I'm going to decompose that. And it's for a very specific reason. It's because I lose letters. So I'm going to put all the A's first. So I'm just going to highlight that in blue. I'm going to put the R's together, and I take a look. There's 2 R's in the word aardvark. There's a leftover D, a V, and a K. So I just decomposed aardvark, and organized groups of identical objects. So I'm counting up the letters in aardvark, and there are 8 of them. But now we have 2 sets of identical objects. Now this is going to be very important. I'm going to put brackets around the denominator. So this 3 factorial represents that I have 3 A's. Now this 2 factorial will represent my repeating objects that are R's, and there are 2 of them. And when I put this into the calculator, what I get is 3,360 different ways I can organize the word or organize the letters of aardvark. Mathematics. Great question. Now, first things first, I'm just going to decompose mathematics. And when I first did this, I actually was missing the letter H. So it's really important that you count each individual letter and make sure that it matches up with your decomposed new word. So there's 11 letters in the word mathematics. Regardless, so there's 11. You know what goes up top? It should be 11 factorial. In the bottom, I have 3 series of letters that repeat. 2 M's, 2 A's, and 2 T's. Now remember, this is just basically permutation with identical objects. Really important to recognize what we're talking about. So I have 11 objects in the numerator, and each of these 2 factorial represent my 2 M's, my 2 A's, and my 2 T's. Make sure you put brackets around that in your calculator. I'm really hoping that you are using your calculator along with me here, simply because you're likely to make a mistake. It is really important. And wow, is this a big number? I believe there are 4,989,600 different arrangements that I can make using the letters of mathematics. Now, naturally, I'm using my calculator to save time. You don't need to hear me click, click, click. But please do this by yourself. You will run into errors. The word Mississippi, like what we've done before, I'm going to decompose my letters. What I notice in Mississippi is that we have 4 I's, 4 S's, 4 P's. Mississippi. So I count up the number of objects that I have in Mississippi, or number of letters, and there are 11 of them. I have 4 repeating I's, 4 repeating S's, and 2 repeating P's. Now, remember when you use your calculator, please put brackets around this. And when I do this, I have less arrangements, and that's 34,650 different arrangements I can make with MISSISSIPPI. All right, so how many different ways can the letters of the word Canada be arranged if the first letter must be N and the last letter must be C? That's a great question. Now, it differs from the ones above. Now, one would naturally think there are repeating elements there, so perhaps I'm just going to write the word Canada in a decomposed way. C-A-A-A. N-D. Canada. There's my decomposed letters. So what's going to happen is I'm just going to arrange these. Now, if you recall from previous lessons, this is a constraint upon us that we need to make sure it happens first. So allow me to, I'm going to use part fundamental counting principle, part permutations with identical objects. So I'm going to put the first letter must be N. So I'm just going to put N right there. And the last letter must be C. So my first decision right here is how many ways can I put N in the first position? Exactly one way. Now, how many different ways can I put C in the last? Well, exactly one way. So now, really, this is 1 times arranging the rest of the letters here times 1. So I've taken care of the C and I've taken care of the N. So we have 4 letters that we are going to arrange. Now they have identical objects, and that we're talking about the A's. And perhaps what I'm going to do is I'm just going to say, I'm going to put the N, there's one way, put the C, there's one way, and now I'm just going to arrange the 4 other letters. Now, how many ways can I arrange the 4 remaining letters? Well, I'm just going to put it in this box. So N, and then I'm going to arrange C, and then I'm going to put in the 4 other letters. Well, hopefully we can recognize that they're A, and D. So there are a total of 4 objects, and I need to divide that by 3 factorial. And what we can see is that this is 4 ways. If you use a calculator, 1 times 4 factorial divided by 3 factorial times 1. Remember that if there are any constraints, you must deal with those first.